And I'm going to turn off my webcam and turn it over to Ken to give his presentation. Let's see.
All right, thanks, Rich, and thanks for everybody. I see we've got a good crowd today. I'll dive right in here, but please interrupt at any time. I will pause fairly frequently so folks have a chance to ask questions because I know you'll need to unmute. And here we go. I should be sharing my screen now.
Looking good.
All right, looking good. So hi, everyone. My name is Ken Casey. I'm from NOAA's National Centers for Environmental Information. Some of you may still know us from the former 3 NOAA National Data Centers, NODC, NCDC, and NGDC. We're now one big, happy National Center for Environmental Information. And shortly after we were born last April on Earth Day, starting in May, a new project was sort of came to mind, I guess is one way to put it, starting with a conversation with the NOAA administrator. And before we knew it, we were being asked whether NCEI would have an interest in taking on a new project to really bring up our data discovery and access capabilities to sort of a modern framework and a modern footing. And so the OneStop Project was born last May, and that's what I'm going to be talking about today. So again, I'll try to pause for questions fairly often so you guys can interject. And I'd be much happier if this was more of a conversation than just me talking. So please do interject as needed. So first, a little bit of the motivation and scope. I think you're all probably familiar at this point with the President's Open Government Initiative, and from that many related policies and guidelines have come down. And so because of this, NOAA, and really even predating it, of course, NOAA has long been committed to providing better and better public access to all of our environmental information, to enable research and commercial innovation, and really focusing on improving the ease of data discovery and use of NOAA's data. NOAA has long been a data provider. This is really about sort of bringing it to the next level and making it even more accessible, even more understandable, even more usable. So this OneStop project really supports NOAA's overall efforts and is organized around this idea of leveraging a lot of our existing technologies and bringing in some specific innovations to really help us do the job better, to provide better data access, discovery, and visualization. It's run out of the part of NOAA called NESDIS, which is where the National Centers for Environmental Information lives. And so it's very much a pathfinder effort with an initial focus on data sets that we're already stewarding. But eventually the idea is to bring it and make it scalable to all of NOAA's data, which is a very, very large and ambitious goal if you know anything about NOAA and the way we're a highly distributed organization with many, many different moving parts. I also want to point out a couple other things going on. So another way we're viewing OneStop is as our activity to help us implement the USGEO Common Framework for Earth Observation Data, which was published earlier this year as an output of the USGEO Data Management Working Group. And I'm sure some on the phone are part of that working group. And we're also taking advantage of a very large and high-profile project that NOAA is engaged with called the Big Data Project. I won't go into a lot of details on this, but the BDP involves 5 of the major commercial cloud providers, and but I will show a little bit more information on that. And we're also interacting with the Big Earth Data Initiative, which is another cross-agency activity. It's implemented within NOAA by funding lots of relatively small data set specific projects to basically improve their data and metadata. But I'll show some more on that. So basically what I want to go through is sort of different segments here. And the first one is how we're really trying to be architected for success. So I'm going to give you some information on the design, the architecture, and our storage concept of operation which is an important one for us. I still hear lots of beeping, so for the folks just joining, please do feel free to interrupt with questions at any time. So this is a high-level view of our framework, sort of the 30,000-foot view. And it's really important to notice here on the left side, we've got this vertical dividing line. On the left side is the stuff that's sort of formally within the OneStop project. But it's very important to point out how we're setting ourselves up for interactions with other projects and other groups outside of OneStop. When they came to us and they said, hey, do you guys want to do this project? We said, well, we're not quite sure. We were actually asked, kind of a nice and surprising thing. We're not usually asked to do these things. We're usually told. And we did last May, we did a quick 3-day feasibility deep dive into this whole thing. And we looked at lessons learned from other similar projects in the past. And what really came out of that was a willingness to take on this project, but under a really key condition, which is that we would be allowed to spend some significant resources not just on the user interface, but on all of these key service layers beneath it. It was clear that a lot of people have put a lot of money into various interfaces over the past, but none of them really was ultimately successful because they had to live within a lot of limitations imposed upon them. So within OneStop, we're actually, our resources are about uniformly split between work spent on the showcase user interface at the top, on the critical catalog services that are used to drive that interface, the metadata that's critical to populate those catalog services, and all of those great interoperable data access, subset visualization, and granular level services that we talk a lot about in our community. Everything from the OpenDAP data access protocol to web mapping services and the like. And then all of that sitting on top of a significantly expanded disk storage capability. Within NOAA, by volume, the vast majority of our data still really are locked away, if you will, on large-scale tape robotics systems. So within OneStop, we were actually resourced to bring a lot of that data online in a much more directly accessible way through these interoperable services. And so a very exciting part of the project is that we can really interact across the boundaries between each of the layers in the cake. And so if one of our user stories says we need a certain functionality in the interface, and we realize, well, then if we want to deliver that functionality, then the metadata needs to contain a certain field that it doesn't already, and that field needs to be indexed into our catalog services. Well, we can actually do that. And so we are doing that. We're iteratively working across each of these boundaries and all the way down from the interface to the storage level and back up again. And importantly, again, I want to emphasize we're setting up a very much an open framework here where other systems can interact with our data and services at whatever level they want. So we talk about the user interface that we're developing as a showcase, really an exemplar to help others utilize our services as well. So if they the community wants to build its own specific custom tailored interface, they can do that, and they can talk right to our catalog services. Or other groups' metadata systems can either talk to our catalog services or come right in and crawl through our metadata WAFs, our web accessible folders. Or if discovery isn't really needed so much and these external groups, data access systems and applications know what they want, they can talk directly to our data through the services as well. So that's at the essence of our framework. I'm going to pause there for a moment. And I failed to mention one thing, and then I'll pause, is that within OneStop, again, we do have all of this disk storage. But as I mentioned, our comprehensive large array storage system class has a lot of our data by volume on tape robotics, and then the big data project itself is in the process of moving some of NOAA's data to the cloud. And we're configured in a way where we can enable discovery and access to those data sets as well. right. All right, done with the awkward moment of silence there. We'll move on and zooming in a little bit and taking a closer look at that architecture. So here's another representation of these different service layers, of course, all sitting on top of a set of security services. We've got our storage capabilities with our dissemination information packages. This is sort of a highlight of some of the key access services, from Hyrax to Threads data servers. Of course, we have our direct download services. ERDAP is part of our model. ArcGIS servers, live access servers, and a WMS proxy capability to help drive the web interface and make it more responsive. We have a set of metadata management services that we're working on, a repository to editing tools, of course the management of these web accessible folders, and a lot of rubrics and evaluation capabilities on that metadata. Within the catalog services, of course, there are things like the extract, transform, load tools, doing things like ranking, working on improving the relevance of our data discovery application, and the user interface services layer with our showcase interface, but also the ability for users to set up their own accounts so that they can do things like track their searches, set up a profile, and then provide feedback and ratings on the data sets. So some key functions or some key features or capabilities or principles at play here. We're really building on a foundation of existing and mature data standards and services, things that we've been using for a long time. Again, we're emphasizing not just the user interface, but the entire supporting data infrastructure. And we're taking what's called a user-centered design-focused approach. Our software development is agile. We're not starting with a big, incredibly complicated architecture diagram that ultimately leaves you dissatisfied. Instead, we're building and designing iteratively based on user stories, and from those stories deriving requirements and doing that in an agile framework. We are required under the new way NOAA, in particular NESDIS, is operating to follow some really key design principles, one of which is don't build something if there's already an enterprise capability that can do it or can close to do it. Everything we do is set up to be a loosely coupled set of reusable components. We're reliant on standards at the interfaces when they exist, and we're directed to use open source whenever possible. I'll pause there again for a moment in case there's a question. Remember, if you have a question, you can unmute yourself by clicking on.
Ken, this is Rich Fozzard, Nashville.
Hi, Rich.
Can you explain? I've been confused for years about the difference between search and discovery. Under catalog services, you mentioned a search engine and a discovery service. Those sound the same to me.
Yeah, so the way I would answer that is this is sort of the internal mechanics of the engine that looks through your index, that finds the relevant things. The discovery service is more what's facing the user, or the set of services that other applications would talk into, like CSW, OpenSearch, and the like. And this is the real.
So search engine is more like the actual tool you use for indexing. The discovery service
like Loop.
Gotcha.
Yeah. Yeah, and thanks for asking that question, because it reminds me to point out this is sort of a state of view of the architecture, and as the project evolves, we fully expect these sort of discrete functions or components within it to evolve as well. So the metadata repository might break into 2 or 3 more discrete components, or the metadata editor capabilities and so forth, or some of them might merge into one. As we refine our capabilities and build out our components, the extract, transform, and load tools would almost certainly break into a set of smaller, more discrete functions as we begin working on those. So thanks for the question, Rich.
Hey, Ken.
Yes.
It's James Gallagher. Can you, yeah,
Hey.
so can I ask you a question?
Of course.
So going back to that previous slide, you know, in that middle layer with catalog services, everybody asks about catalog services. Can you explain a bit more about data ranking?
Yes. So one of the things we're very interested in at NOAA, because we have so many data sets and many of them being fairly similar, is how can we better return a ranking of search results so that they're more appropriate, or they do things like show more mature data sets higher up in your lists. Ranking is sort of the longer version of that phrase. I will go into a little bit more detail on that in some of the later slides.
Okay, cool.
All right.
Thanks.
Yeah. If I, just in case I forget to say it later, in our original project plans, we had some really, really huge and very ambitious goals for this piece that involved all kinds of external analytics about data usage and things like that. We had to tone down our ambitions a little bit when we got our actual budget, but we still are doing some significant things in that area, and I'll get to that in more detail.
Cool. Thanks.
So another way to think about what we're doing here with OneStop, again, NOAA is it's a distributed organization. We have data all over the place, and even just within NCEI, we're managing multiple disk stores across our different geographies. I didn't say it at the beginning, but even after the merger of NCEI, we still have all of our three main geographic locations for archive storage at play. We also manage data in the class tape robotics, and then I mentioned also the big data partnership projects and the cloud storage. So another way to think about OneStop is, how do we make our users happy, smiley face, by providing them a real and true integrated discovery and stewardship and access services. So there are a lot of what I would call redirection portals out there, right? You go to data.gov and you can do a search and you can end up at some other site. So yes, there's an element of that in OneStop, of course, but we're actually going quite a bit further to really try to integrate and bring into a consistent experience so that users aren't just being redirected to yet some other interface, yet some other new tool that they have to look at, but really actually trying to bring in an integrated discovery, metadata, stewardship, and access services, regardless of where the data are stored. We do have a part of our plan where we'll be doing a professional usability study. There's sort of a notional success goal of 2/3 of the users tested prefer the new interface of the old, but we'll have to make sure that that's a reasonable, once we bring in that professional review team, they'll help us make sure that's a reasonable number to be shooting for. I see a question on the chat. Is the OneStop model to give users tools to find the data sets required, then enable data transfer to some other platform for processing and analytics? That's a great question, and what I would say is yes. So we're focused principally on the discovery and access capability. So within OneStop, we're not providing any kind of cloud or otherwise providing processing capability. So number one, we have to enable sort of the traditional paradigm of user comes in, finds data, and downloads it, and then processes it wherever they want. However, with that said, we are trying to move more and more in the grand scheme of things, NOAA's access to the cloud, and that's the basis of the Big Data Project, which is a cooperative research and development agreement with Amazon, Google, Microsoft, IBM, and the Open Commons Consortium to put more and more of NOAA's data in the cloud. So for the data sets, for example, NEXRAD Level 2 data are already out there in the cloud. If a user finds that through OneStop, they will see that NextRad Level 2 data are in the cloud and that they can go there and work on it there. Okay, let me keep moving because there's a lot more to cover. I like to include this slide in these discussions, even though in a lot of ways, you know, I know the external community doesn't really care about this sort of thing. But it's really one of the major things that NCEI is going to do is kind of this very nitty-gritty thing. So we're standing up a whole bunch of new storage, about 2 petabytes initially, within our Asheville site. But the great thing about it is we're going to be breaking down a lot of our existing barriers so that we'll be able to read and write, read from and write to that storage from all of our different locations, which right now are all within these different, what are called FSMA boundaries, these different IT systems. And that's a pretty big deal for us. And it's taking a lot of work, and we're making great progress on that. And so I do like to show that because even though it's not very glamorous, it's an important feature. And as I mentioned, we'll also be able to read from the class system as well as point people to the data in the clouds listed there and that are in the Big Data project. Okay, so just to give you a sense of what we're working on, as part of the original plan, we focused on delivering several different what we're calling data groupings. I'll try to explain that in a minute. And make sure that they're what we've been loosely calling one-stop ready, and so that any data set that is one-stop ready should really shine in our showcase interface. So again, this goes back to that idea of we're able to iterate between the sort of the needs of the interface and the catalog services and the metadata and the data sets themselves. And so we've got a group of people working on improving the readiness of various data groups to sort of carve the path, to set the stage, to give some good exemplars for others to follow. Now, what does it mean to be one-stop ready? So we've established several metrics for that. So one, of course, is the metadata for the collection has to be ISO compliant. And every record within a group of these relate what we're calling a data group. A data group is a collection, a data group is a set of from 1 to n collections of data where a collection has an ISO record. So in order to be one-stop ready, every collection within the group has an ISO metadata record. We have an ISO completeness rubric that's applied, a new version 2, and every collection level record in that group has to have a score of at least 90%. We have some additional specific things that are emerging as sort of new requirements for our collection level metadata. So for example, we've been mandated to really bring in a whole new level of sort of visual appeal to our interface, and so every data set has to have a good browse graphic. We're migrating all of our data to incorporate GCMD science keywords, for example. So that's part of the one-stop rubric. We go further beyond just the collection and also to the granular level. So for each of these data collections that may have one to many granules within them, we are building standardized metadata for that, and with a real focus on ACDD and CF conventions for the embedded metadata and things like a NetCDF granule. We've established a set of required content for those granule metadata records. I won't jump to it, but we have a specification there where it's essentially a light version of ISO. Since the collection itself has a nice complete ISO record, we're focused on a more streamlined set of granule metadata. Okay, so in terms of readiness, we need to make sure that the data files themselves are in a machine-independent format with a preference on NetCDF. Each granule has to be accessible online through a URL with at least direct transfer, but I'll show in the end of the presentation with a real focus on the interoperable services that are outlined and highlighted in the USGEO Common Framework. And these last two bits get to some of the things that you were asking James earlier about the ranking. So Ji Peng, who, as many of you know through ESIP, has worked with the community extensively to develop a data stewardship maturity matrix capability. And so for OneStop Ready data sets, we're putting each one of them through this DSMM assessment process. And I'll show a little bit more on what that looks like later. And then optionally, there's another similar thing called the Product Maturity Matrix that the NOAA Climate Data Record Program has established. And for us, we view that as optional, but if it exists, we have a way of capturing that in the collection metadata. And so we really focus on this, and we consider the whole group of data collections OneStop Ready when we hit a 95% or higher overall score. So I know that's a lot to sort of say in a couple in a couple minutes on one slide, but the bottom line is when we started this whole project, we had the concept of OneStop Ready. We now actually have a set of discrete quantifiable rubrics that establish when a data set is OneStop Ready. And these are the data groupings that we're focusing on. The three in bold are the ones we've done the most work on so far. The first two are digital elevation models. There's 137 data sets or collections, if you will, in that data group, and those are at 100% readiness. Our co-ops, which is an operational center within NOAA's National Ocean Service, has a data, this case is a single data set, a single collection from the National Water Level Observing Network and the Physical Oceanographic Real-Time System ports. And that one's also now ready. But you can see we're working on a sort of a wide range of other data sets. So we've got a real mix here of in situ and satellite, derived product, more fundamental or direct observations. We've got some really exciting project going on with satellite imagery that is currently only on film from the 70s, the early ESIP missions that we're digitizing and putting into NetCDF, so that'll be an exciting one. So these are the ones we're focusing on. They're handpicked based on a set of pre-established priority data sets, and we've selected sort of a mix of things to help document and sort of test out the problem space, if you will. You know, we don't want it to be just satellite data, but we want it to include in situ data and so forth. So if we can, we can really see that our processes and our approaches will make sense across NOAA's truly vast diversity of data sets. All right, I'm going to pause there for a second.
Hey, Ken, you had a nice definition, I think, of collection, what you consider a collection and a granule. Are you going to get to that, or would you like to?
I don't know if I show that on here. I think you're referring to the idea that a collection is the minimum citable unit, and a granule is the minimum discoverable unit.
Yeah.
Is that
yep.
what you're referring to? Yeah, you know, I don't think I put that on the slides. But yeah, this is something we've had to deal with because we came up with a third term, this data group, because these groups have either somewhere between one and many thousands of individual collections. So an individual collection is documented with an ISO collection level record, and can, and many of these do or will, have DOIs at that level. Each collection itself can then consist of from one to many granules. And a granule is typically an individual data file, but we're set up in such a way that the granule could actually be a piece of a data file, particularly if it's a nice interoperable format like NetCDF.
Great, thank you.
Sure. So just to give you a sense of progress, back in April when we really got started, this was kind of our initial sort of readiness status view in these different categories. So an overall percent readiness, how ready were the collection metadata, the granule, the data formats, and so forth. And now that the team's been working on it for a solid 3 months, we've made a ton of progress. We're very excited about where we're heading with this. And so we'll continue to update these, this sort of view of it on our progress on these individual data sets. I'm not sure if there's anything else I really need to point out on this other than, you know, toggle back and forth. We're definitely making a lot of progress there in short time, which is one of the exciting features of having a project where we were actually able to fund, you know, new people working on things without being distracted by 10,000 other activities. And this is a good example of how we can make a lot of progress fast when we can do that sort of thing. Okay, so let me dive now, so kind of switch gears from sort of the focus on the data sets and before that the design and architecture to where we stand on the user interface. One of the very first things that our Agile team did is after collecting, of course, all of our user stories, they began to work on some wireframes and exploring based on the way those user stories were leading into some requirements that outline different sort of ways of interacting with the data set. So, and I should point out we're really relying on the standards.usa.gov site, which is really an attempt by the U.S. government to establish a set of consistent standards across the federal web space so that users can experience a more consistent, or users can have a more consistent experience when they're on a NOAA site versus a NASA site versus a USGS site. And we're adhering to those, and that's really helping sort of modernize the overall web presence. And I should note that NCEI itself is doing the same because we're engaged in another activity where we're revamping our entire website. But just to point out a couple things from the initial wireframe, one of the things that we're really interested in is being a little bit more proactive in our discovery. Right now, all of NOAA's discovery interfaces are pretty passive, but what we're setting up is to be able to sort of push information to users. And as we get more sophisticated, some of the, you know, just like, you know, when Netflix knows you're watching history, you're viewing history, it can show you some more relevant things. We have interest in being able to do that as well. So that's one view of one of the initial wireframes. Another would be a very simple search, like a Google-style search. Another would be to highlight that, you know, our ultimate interface will have faceting capabilities, or be able to group the results by different things like perhaps the instrument or the data provider, where each collection is represented by a card on screen with a nice visual, nice browse graphic representing it. We see sort of a need for kind of different views, whether it's this sort of icon grid view or a map-based view of the results or a simple list. And we're also got exactly how to incorporate this idea of what we're calling apps for now. So we know that many of NOAA's data sets already has a many NOAA data sets already have a nice sort of customized application built around them. So we don't want to lose that. We don't want to forget that, or we don't want to not show it to the users. And so we're trying to incorporate in the interface that idea so that when you find a collection of interest, if it does happen to have some kind of tailored or customized interface to it, that we'll want to be able to expose that to the user. That's sort of a sense of what the map results might look like. And but I think more interesting right now, perhaps for this group, would be a little bit more on what's under the hood of all of this. So without, and I'm looking at the time, so I'm aware of that, without going into too much detail, I've already talked about how we have data in these different systems, whether they're in class, our Asheville, North Carolina site, our Silver Spring, Maryland site, or our Colorado site. Currently, and I should point out, currently we're hoping and working to really sort of consolidate and integrate a lot of these capabilities. But as they stand right now, we have multiple ways of managing our collection and granule metadata. So the Agile team has started with just two of the data sets, one from Maryland and one from Colorado, and is pulling the information, in the case of Maryland, straight out of the existing GeoPortal into the very latest version of the GeoPortal that we've been working with on Esri, bringing Elasticsearch under the hood of the GeoPortal. And then in the case of the Colorado data set, directly pulling in from a web accessible folder and basically reading all of that metadata into Elasticsearch, which is going to form the basis of our capabilities. So we really see it as a combo pack, if you will. The GeoPortal plus Elasticsearch provides us with a set of interoperable discovery services that we can then utilize and expose to the user interface, and as well as to the broader user community directly as well. Some of these other services I've mentioned we haven't started working on yet, the analytics, security services, and the sort of user authentication and profile management services. So I've already said a fair bit of it, pulling data from these existing pieces right now, writing the metadata to Elasticsearch via what we're calling this API, which I don't want to scare people too much into thinking that we're creating some custom API, but because we are relying heavily on the existing capabilities of Elasticsearch and GeoPortal, but in areas where there are no existing APIs, we're kind of wrapping that into this box called the OneStop API. And then bringing it into this new consolidated GeoPortal for CSW and OpenSearch. So our server API translates JSON requests that are generated from the user interface into an Elasticsearch query. We have some basic capability for temporal and spatial searching in addition to simple text, and right now we're just kind of focusing on the top 10 results. Now, a couple other things we're bringing in, those are the two data sets. We have this concept for sort of a basic interaction model with the results are through what we're calling these flip cards, and I would love to demonstrate it for you, but you're going to have to wait till next week at the ESIP meeting. But essentially, if you go back to these wireframes, each of these cards representing a data collection will essentially be able to flip. So you go from a nice visual view, and it can flip around and highlight on screen so that you can read more details about that particular collection. And it's visually quite appealing and allows you to kind of go through your results rather quickly as well. So it's functional and appealing. And of course, we have to bring in things like the NOAA look and feel and so forth, and refine the spatial and temporal search capabilities. So the user interface demo will be next week at ESIP. So hopefully many of you will be there. If not, in the imminent future, our interface, which is still, it's an early alpha phase, but we have built into our plan numerous beta testing opportunities. We already have a list of about 15 or 20 people or so who at the January ESIP signed up to join our alpha and beta tester group. So if you're interested in doing that, please email me afterwards and we'll add you to the list. So we'll actually incorporate you along the way as each of our sprint cycles goes on. So I'd be happy to tell you more about it if you're interested. So whip me off an email and let me know. And I see some of the folks on this list are already part of that. Okay, so a couple more things that I've got to speed through. We're really just launching into a very exciting part of this. It's pretty clear that when NCEI was merged, one of our big challenges is doing consistent and rigorous metadata with our staff across all of our sites. And so, since this is an obvious connection with OneStop as well, one of the key pieces is the development of a new metadata tool that we hope to then use across all of our systems. One of the things that our team did initially is took a look at some existing tools. We have a tool called ATRAC down in Asheville. We have the system used in Silver Spring called AMS, and it's an accession tracking database. Some tools in Boulder, DocuComp, and CEdit. We have an ingest capability called, for receiving data from producers called Send NCEI. And then, of course, there's some metadata capabilities within things like the GeoPortal server and GeoNetwork and Mermaid and evaluation tools like EMMA. I'm not going to go into the details of this analysis, but we basically mapped the capabilities of these existing systems against our initial list of metadata requirements, and we found that, of course, as you would expect, none of them really met all of our needs, but a path forward, which is shown here, was really highlighted. I see a question about which GeoPortal. That's the open source GeoPortal server that Esri still maintains, but this is open source, not like the GEOS GeoPortal, if that's the point of confusion. We're now working on sort of architecting up the metadata tool system. This is what it looks like. Again, we don't have time to go into huge details, but basically we're dealing with all kinds of input metadata. We have a real key need for adapters and validators to bring that metadata into a new centralized metadata database that the technology for is still being examined. It won't be Oracle because NCEI is trying to move away from Oracle. But that database would hold essentially these, character large objects, big text blocks for collection metadata records as well as granules. And I should point out, we have many billions of granules in the NCEI archive already, so scalability and performance are a key feature of this. We know, of course, we need a set of metadata tools for our happy human metadata editors to utilize. And then on the output side, through our extract and transform and load capabilities, we move that metadata into that combo that I talked about earlier, the GeoPortal plus Elasticsearch, our web accessible folders, and then other services, things like OAI, PMH, and so forth, to feed all of the many different groups that we need to feed, one of which, of course, is our OneStop user interface, but we're also required to populate the NOAA data catalog, and I see Chris McDermott on the phone. We also expose our metadata to Google with things like schema.org capability embedded in that. But we interact with a lot of other groups too, the World Data Systems, the WMO Information Systems, CEOS WGIS Integrated Catalogs. I could go on and on and on. So this is the overall concept for our metadata tool system. Our metadata tool developers just came on board in the last few weeks and are already diving right into this. Oh, and I forgot to mention Cabana, which is a capability we don't have yet in-house, but it's an approach toward being able to do sort of a dashboard kind of view of your metadata and services. So don't have too much more on that yet, but the idea to be able to sort of analyze and visualize our capabilities would be tapped into that as well. Another thing the metadata group within OneStop is working on are tools to make the data stewardship maturity matrix assessments easier. That's one of our early lessons learned, is that's a pretty, to try to apply this to 1 or 2 data sets, no problem, using a lot of the existing methodologies, but when you want to do it to 80 or 10,000, it's another thing entirely. So working on things like a graphics tool to help visualize the outputs. This is actually for our National Water Level Observing Network data set. And you can see the greens are where it scores, plus a view of it in stars. Like it reaches 5 stars in terms of its preservability, 4 stars in terms of accessibility. But because it's an operational data stream, it's weaker in terms of the data quality assessments. And so part of our improvement on data rankings that I mentioned earlier will be to incorporate these kinds of assessments into it. So all things being equal, our data rankings would show more mature data sets higher in the results. And Peng has a session on Tuesday of next week at ESIP, so hopefully you can catch more on that there. And one of the last things I want to cover, actually I have a couple more things, so I'm speeding right along here, but keep the questions coming if there are any, is really trying to be very systematic in how we deliver on basically all of the features or the functionality called for in the USGEO Common Framework. This Common Framework for Earth observation data, there's a link to it. It was published earlier this year. What I tried to do is, the way it's written in the USGEO, it's written in 4 groups: discovery, access, documentation, and formats and vocabularies are grouped together. I split them up for the purpose of trying to go through the document and very explicitly call out in a succinct way the capabilities that the USGEO Common Framework is identifying as best practices for the federal agencies. So in terms of discovery, it says you should provide your metadata, your data through CSW and OpenSearch, and you should use Project Open Data and schema.org in data. You should mint DOIs for your data sets. You should publish a WAF to data.gov and also expose your holdings via OAI PMH, and so forth. So in Access, it's a lot of the things that this group, I'm sure, is familiar with. For gridded data, you should use WMS and DAP and so forth. And unstructured grids, you should use UGrid, and so on. And so I went through that entire document on a very long plane ride to Korea and pulled out everything being called for, and then tried to map on this next slide the ones that OneStop is currently addressing. And you can see where the solid green is the things that I think we're hitting on very solidly. Dashed green a little bit less so, and no green are the ones that we're not really touching very directly yet. And so it's kind of a good news view in that we are really hitting a lot of the key points from the USGEO Common Framework right out of the gates. And kind of saving it, the best for last really are the people behind this project. And I did want to put their names on screen in this next few slides because I really want to encourage, and many of them are on the call, so thanks everybody on the team for joining in. I wanted to show you where they are and what their names are, because the likelihood is that you'll rub shoulders with them at some point, whether it's at ESIP or maybe you're visiting one of our data center sites or at Fall AGU or wherever it is. I wanted you to get the names in front of you. So just quickly, within NESDIS, so the head of NESDIS and his deputy, and then through Tom Carl and our CIO's office within NESDIS, I report to all of them as the project manager. One of my key things is what I'm doing today, which is engaging the user community, but also within NOAA, really focusing a lot on engaging the other parts of NOAA, so that we're really doing our best to make sure that whatever we deliver is, not just palatable to them, but downright tasty. We have an integrated project team featuring key stakeholders from mostly across NESDIS. And then the project itself is organized into 4 key teams. We have our Agile team, led by Dave Neufeld out in Boulder, our architecture team led by Dave Fishman, also in Boulder, our IT tools and services team led by John Relf here in Silver Spring, and our metadata and data improvement team led by Nancy Ritchie in Asheville. So we're at our heart a very big project as well. And I'm not going to read everybody's names here, but this is another view of that, where we have the different teams, and then while some of the teams, like the Agile team, maybe that's the only one really, is centrally located in one position, all of the other teams really have a high degree of distribution across our 3 archive sites. And we're lucky also to have folks like Jackie Mize and Kathy Martinowicz down in Mississippi contributing as well. So we've got a good group of people. I've highlighted here the ones who are really more or less 100% focused on this project versus the one, particularly our existing federal staff who have other responsibilities. But we've got a good mix here of sort of people who've been around a while, and then a bunch of new folks, really talented new folks who are much more focused directly on this project 100% of the time. I put a little check mark next to the folks that I'm aware of who are going to be in ESIP, or going to be at ESIP next week. Myself, Nancy, Dave Neufeld, and then Evan McQuinn and Ariana Chikozits from the Agile team. So definitely recommend that you guys take the opportunity, whoever's going to be there next week, to introduce yourselves to these folks and give us your feedback, because we definitely want to hear it. Just a couple wrapping up things. I wanted to highlight our schedule for you guys. Our public beta release, sort of a fully operational beta, is scheduled for December, just prior to the fall AGU meeting by design. There's then time to do some more sprints, and then we have a full 1.0 release next spring, followed by a professional usability study, and then learning our lessons from that and doing another release by next summer. And this is just sort of a summary of accomplishments. I think I've mentioned most of this already. We're 5 sprints in on the Agile team, and we'll demo our initial functioning user interface next week. And just to highlight that we'll have a session on OneStop next week. It'll have a lot of these same slides, but don't let that discourage you, because the other great thing we'll be able to do at the meeting next week is really discuss a lot about that mapping to the common framework for Earth observation data, and it'd be great to get some conversation going about how the other agencies and groups are addressing that. And we'll also have time dedicated to really doing a live demo of interface and getting your feedback there. So we're very excited about that. So I think we have a few minutes left, and I'll stop speaking there and see if there are any questions.
Just a reminder for people to unmute themselves.
Hey, Ken.
Yes?
It's Ted.
Hey.
I just wanted to, since you gave such a good talk as usual, no one has any questions, I just wanted to thank you for such a great and clear talk.
Oh, well, thank you, Ted. That's very kind of you. Appreciate that. Appreciate you getting my back for me there.
Well, yeah, I mean, I was waiting to say that at the end, but I mean, if there are no questions, this to me it's so exciting, because it's like light years ahead of what NODC used to be about, at least, you know, in terms of what we all at least perceived of NODC being, which was sort of like a place where you park shoe boxes of data, and you know, you can go retrieve them in the future. But it's so exciting to see these services that have come out of the community and that are being, you know, the OGC services, and being supported, and old data, you know, is going to come to life through this, and it provides a clear place where people who don't have the ability to host their own services to do this stuff, and you know, can send it along, and yet have it accessible through all these modern services that we're increasingly becoming dependent on. So I think it's just tremendously exciting. So again, thank you very much for this presentation.
Thanks a lot, Rich. And I should add another one of the activities. I didn't really go into my current role, but within NCEI, I'm the Deputy Director for our Data Stewardship Division, which is where so much of this stuff lives. And one of the activities I'm working on right now with a just incredibly talented team of folks from across our different locations, some of whom are on the call, is to work on a technical roadmap over sort of roughly the next 5 years. A lot of what I presented today is really informing that roadmap, and those services, all of those capabilities that you were just talking about, Rich, there's no doubt those are all going to be really central to our future, and as well as really bringing more and more cloud capabilities into play. So it's an exciting time within NOAA and within the National Centers for Environmental Information to really be able to try to push forward in a big and concentrated way. A lot of people, going back to the earlier days of my time in NOAA, have been trying to do this stuff. And finally it feels like we're getting some traction, we're getting some resource, and getting some serious momentum to try to do it not just in sort of a piecemeal way, but to do it in a big way. I see Dave Blodgett asked a question, is there a location we could go to find a catalog service endpoint to get at collection metadata records? Specifically interested in GeoIDE compliant collections. There will be. Right now we have our WAP sort of spread out across our different sites, but as part of the OneStop framework, there will be a centrally consolidated one. And Anna Milan is pointing out to me to remind people that we do, of course, have our data.noaa.gov collection where all of NOAA metadata is brought together. I see Bob Simons has a question. Have you considered using ERDAP for in situ data? Yes. In fact, ERDAP is on our diagrams there. So TableDAP, which is part of it, of course, is in our plans, and within our list of key services there. Here we go. ERDAP. In fact, ERDAP's right in the middle of them there. So yes, that is one of the things we're trying to roll out to into the OneStop framework now. Good question about OneStop API documentation. No, not yet. And it's one of the things we can certainly talk about in more detail next week at the ESIP meeting to sort of solicit input on how best the community would like to see that documentation provided.
Okay, well, let's hold the questions there. Ken, thank you again so much on behalf of the ESIP IT&I committee here, Ethan and myself and the whole community. Have a great meeting next week, and we'll see you guys here on the webinar in a month. Bye-bye, folks.
All right. Thanks, everybody.